Close enough that they're selling candy and Halloween decorations.
Afternoon. We're going to be discussing some absolute value equations today. This is going to be one of the little shorter assignments following up that intense assignment the last time with a lighter one. I think there's only 7 problems assigned in the homework on this one. And
is that why you have like 2 days to do it?
Those due dates are just to help you move through. I try to give you basically, if we do it on one day, then at the end of the week, Friday, Saturday, something is the due date. But for your homework, you can always work on any of the homework assignments even after the due date.
The due date's
okay?
just a formality.
Yes. If you see, look here, the first assignment is past due, but I can still click on it, and I can either practice and review or just improve my score. I think I have 100 on the first assignment, so I don't need to improve the score. I would just say review and practice. But if you haven't done a problem, the first one, you can always just click it and then say improve score. I always access the course by hitting on the Pearson homepage, clicking My Lab and Mastering, open My Lab and Mastering. By doing that, I get to see the Pearson homepage. And, not that there's much there, but when I click the Pearson assignment buttons, there everything is. So, today...
Theoretically, if we really want to, we could just do all the assignments at once.
Sure.
Or is there like an opening time for some of them?
No. Well, there's the prerequisites. I can't do assignment, well, I could because I'm the teacher, but you can't move to assignment 8 until you've made a 70 on assignment 7. Every assignment has prerequisites, and so you've got to just move through in order, not with, you can't just jump through the course. There's a variety of reasons for that, one of which is, as soon as a student clicks on a homework assignment, the teacher cannot edit it any longer, even if I realize, oh wait, I don't like that problem, I want to, do something else. Teachers can't edit it then.
And I'll give you an example, okay? Here's an example of how we edit it. Remember the real messy square root equation on Tuesday? We had one just like it on the first test.
And the first review. We went through, because no one had clicked on it in this class, I was able to go through, remove that problem, and put in I think it was a cube root problem or something like that. But it was one of the ones that wasn't the super messy square root equation where you wind up checking with fractions. Oh, I don't think that's on. I'm not on? Do y'all hear me over here? Is this on? No? Huh. Oh, wait, Tim, do you think that they messed up the volume when they were working over there?
Yeah.
Because my little green light is on.
Wait a minute. Can you hear me?
Yeah.
Yes.
Can you hear me? No? Well. Huh.
The fact that they're answering...
These are alkaline batteries, and they don't last very long. I'm going to...
Okay, so today we're going to be solving absolute value equations, and I'm going to review a little bit about absolute value first. If we think of the real number line with 0 in the middle, the positive numbers are on the right, and the negative numbers are on the left. Telling you something that you know already, and I know you know that already. But the sign, positive or negative, indicates whether it's to the right or to the left of 0. So that would be like east or west. And then the number We could think of that as the distance from 0 or the magnitude. So like -2 is 2 units to the left of 0. The 2 would be called the absolute value. In general, I'm not drawing an 11. It's big vertical bars. The absolute value of 3. How many units from 0 is the number 3? Well, that's easy, 3. What if there had been a negative number inside here? The absolute value of -3 would also be 3. The absolute value is the distance from 0. What's the distance between -3 and 0? Distance does not make sense if it's negative. If someone asked you, what's the distance from here to Houston, and you said, well, that's -220 miles, that doesn't make any sense. Distance is never negative.
There could be a chance where distance could be negative, but it's more of like, hey, where was this?
Not by the definition of distance. Okay, not by the definition of distance. If you're trying to say, okay, it's north or south, and you put up a grid line then, okay, you can say it's 220 miles north. That would be the equivalent of positive or negative. In general, it doesn't matter if the number inside the absolute values is positive or negative. Inside the absolute value bars, you could have a positive number or a negative number, regardless of what. This number over here, where my pen is, the one on the right, is what? Always going to be positive or always going to be negative?
Positive.
Always positive. If we had something like the absolute value of 7,
then it would be 7.
That's 7. What if it had been a -7 inside
It would
here?
still be 7.
Still be 7.
But
It's okay to have a negative number inside the absolute values. You can't have a negative number over here on the right, outside the absolute values. Then we put a plus minus in front of the 7. So the absolute value of positive 7 is 7, and the absolute value of -7 is 7.
what if we get a question where it doesn't give us the absolute value, but gives us like the distance? Do we do
Oh,
like
well,
for like the first one?
what we're going to be doing is solving equations that have absolute value bars in them. Okay? Let's look at problem number 1.
Yeah, that's why I asked, because I saw it.
Oh, well, I guess that's why I got the 7 there.
Yeah, so
yeah.
would it be technically 7, -7?
This is problem number 1. The absolute value says solve this equation. Absolute value of x equals 7.
So the answer would be 7, -7?
Yes. There's two numbers that could go inside these absolute value bars, positive 7 or -7. And so, since I've already basically done this problem, Tim, why don't you punch it in and then we'll check it and get a different one. Okay, this is one of those problems. Your first problem, you should, you just put the plus minus.
Right.
You see, he just put 7. Now put the plus minus in front.
The math still said it was wrong.
Well, what about, here's a similar question. Solve the equation. Absolute value of x equals 6.
Plus -5.
5. Okay, 5.
Plus -5.
Plus minus 5.
I have a question for the class, okay? I know I was supposed to keep my
You
mouth
don't
shut
have to.
because this was going to be your video, but still, I have a question for y'all, okay? Can you get rid of that window? I'll write right here, okay? So, suppose, okay, we've already said the absolute value of 7 is 7, the absolute value of -7 is 7. Here's my question. The absolute value of what? What can you take the absolute value of? What can I put in here to give us the absolute value of equaling -7? What can we put in here? Nothing. No
I'll
matter.
tell you the wrong answer. If you look at the video, this is what I did when I made that first video. Here's what a lot of people would do incorrectly on that. They'd say x equals plus minus 7. No, no, no.
If you have an absolute value by itself on one side and it's equaling a negative number on the other side, then that cannot happen. The absolute value of nothing is going to equal negative 7. Okay, I'll be quiet.
So what he was trying to say is something that you'll use for problem number 2. If you have absolute value equals a negative, then the solution is well, there is no solution. You could write it either way, depending on how they write it on Pearson. Either say no solution or an empty set for the solution. Okay, no solution or empty set. Let's see, what is that problem number 2? I hope it has some number in it other than 7. We've been using 7 too much. Okay, problem number 2. This is another problem that you can sort of do without writing anything down. Solve the equation absolute value of x equals negative 13. What is it? Oh. Absolute value of x equals negative 13. You cannot have a negative number over on the right-hand side.
Provided the absolute value is, there's nothing else there on the left side.
Yes. So this is one of those, what are they saying as the option? No solution or empty set? B, empty set.
Any questions there?
Oh, we've done 2 of the 7. We're just flying along.
Oh, maybe we'll get into homework number 8 today.
Oh, maybe not. Well,
no, you can't.
We have absolute value x minus 8 equals, is that a 25?
Mm-hmm.
This is one of those times when hopefully you can understand the logic of why. You may not, you may know how to use the quadratic formula, but you might not be able to explain why it works. I didn't try to make that explanation. But for this one, this is something that you can understand why we're going to do what we're doing. If I covered up this x minus 8 right there, what are the only 2 numbers that could go inside those absolute value bars?
Negative 25 and 25.
Okay. The only 2 numbers that can be inside there are positive 25 and negative 25. So you're going to take what's inside the absolute value bars, set it equal to positive 25 and negative 25. And is this an equation? Are those 2 equations you sort of know how to solve?
Yes.
I bet you do. What kind of equations are they? Linear or quadratic? Linear. There's no x squared in it. If you wind up with a quadratic equation in this assignment, you're doing something wrong. Something very, very wrong. Okay? So how do I get this x by itself right here on this one?
Minus it on both sides.
Unless I miscopied it, it's going to be plus it.
Plus 8.
Yeah, add 8 to both sides. So I'll first, I do the little arrow. So we get x equals 33.
Yep.
And what about over here? Add
Negative 7.
8. Now, sometimes people get carried away and decide the answer is plus 33 and minus 33. No. It's 33, and what's this one over here? The negative 25 plus 8 is
17.
negative 17. So we have 33 and negative 17. Okay. And is it clear? This is something you could check pretty easily. And I don't mean check by punching into Pearson to see if it gives you the answer. Plug a 33 in for x. 33 minus 8, that gives you a positive 25. and the absolute value of positive 25 is 25. If you plug the negative 17 in, negative 17 minus 8 is negative 25. Absolute value of negative 25 is 25. So we don't even need to check it. I know it's right, but go ahead and do it just so we can get credit for the problem. 33 comma negative 17. Okay. Let's do another one like this one. Any questions? Are y'all following the logic? After that last assignment, this should be a little less involved. Let me see. Problem number, well, I better move to another page for number 4. Yeah.
This one looks like it might be good.
Okay, so I'm writing number 4 down. Absolute value. This is not 21x minus 11. It's absolute, 12x, yeah. Absolute value of 2x minus 1 equals 6. Well, even though it looks more involved than number 3, you follow the same logic. Imagine that you don't see the 2x minus 1. What are the only two numbers that can be inside these absolute values?
6 and negative 6.
6 and negative 6. So what am I going to do? I'll take what's inside the absolute value bars, set it equal to positive 6, and then set it equal to negative 6. To solve an absolute value equation, you go equal positive, equal negative. You take what's inside the absolute value bars, go equal positive, equal negative. Now, let's see. It's a little bit messier than the other one, but not that bad, is it? What would I do to get the x by itself now?
Add 1 on both.
Add 1, so we have 2x equals 7.
And on the other side, 2x equals negative 5.
Oh, okay. Well, I'm going to finish this one before moving over there. What do I do now? Divide by 2. So we have x equals 7 over 2. I'll circle that in purple. There's one of my answers. Now over here, add 1. So we have 2x equals, let's see, negative 6 plus 1. What am I going to put right here? Negative 5. And then
divide both by 2, so x equals negative 5 over 2.
Divide both sides by 2, so we have x equals negative 5 over 2. Okay. So we have 7 over 2 and negative 5 over 2. Do you want to punch them in, Tim? And notice, even if they'll allow you to put that comma in the denominator, don't do it, because when we get the next homework assignment, they'll be counting it wrong. Any questions? So if we just have absolute value equal a positive number, you go equal positive equal negative. If you have absolute value equal a negative number, no solution. I'm about to write a rule, and if you're thinking this is where it's going to get hard, well, don't panic too much. I'm going to refer to this as one of my red star rules. I'm going to put a couple of red stars by it. I'm going to say it 3 times, but only write it once. Always, always, always isolate the absolute value bars first. Always, always, always isolate the absolute value bars first. what the heck do I mean by that? Well, notice on problems 1, 2, and 3, on the left-hand side, we just have absolute value bars. There's nothing with the absolute value bars on the left-hand side. So see what the heck I'm talking about? If you look at number 5, let me see. What does number 5 look like? Oh, is that an absolute value of 7x, then a minus 3 equals 52.
32.
32, oh my goodness. 32. There's only one correct first step. Only one thing you can do to begin this problem and be doing it correct. And it has to do with those red stars up here. What am I trying to say we need to do here on problem number 5 first, before I do anything else? Add 3. Y'all hear that exactly right. You've got to get those absolute value bars by themselves. And the way I isolate the absolute value bars is by adding 3 to both sides. So we have absolute value of 7x equals, is that a 35? 32 plus 5? The wrong thing to do would be to start off by going equal 32 equal negative 32. If you find yourself getting one answer right and one answer wrong, then that's what you're doing wrong. You're not isolating those absolute value bars first. Now that it's in this form, absolute value equals 35, how am I going to solve it from there? What am I going to do? Well, take what's inside. And you're thinking, what's the only numbers that can be inside here? Well, either a 35 or what's the other number? A negative 35? Once you have it in the form absolute value equals a positive number, you go equals 35 equals negative 35. And is this pretty easy to solve for x now? What will I need to do? Exactly right. Divide both sides by 7. And we get x equals 5. 35 divided by 7. And over here, what are we going to get? Divide by 7. Negative 5? I think that's right. So 5 and negative 5. You can punch it in with plus minus, or you can just list both of the numbers, 5 comma negative 5, however you want to do it. And you're doing it with 5 comma negative 5. Okay? Always, always, always isolate the absolute value bars first. I say that 3 times. And then, or at least I say always 3 times. And then number 6, do I have to isolate the absolute value bars here? Well, I think they're already done. Right. Just real fast, move to number 7. I think number 7 is one where you got to isolate them, right? Yeah. Okay. So that's number 6. Usually I always say, oh, the last one must be the hardest, which I always say that, but it's usually not. You might be thinking, oh, wow, number 6 is the hardest because it has a fraction. Let me write it down. The absolute value...
I thought you had written it down.
No, I said let me write it down. Of 2x minus 5 all over 3 equals 9. But don't let the fact that there's a fraction in this scare you. In fact, it's no harder than any of the other ones. You know how to solve an equation with fractions. So if I cover up that 2x minus 5 over 3, here's my thought process, my logic. The only two numbers that can actually be inside here to equal 9 would be positive 9 and negative 9. So take what's in there, set it equal to positive 9, and then set it equal to negative 9. I believe it was problem 6 in the last assignment about solving rational and radical equations. We had an equation that was fraction equals fraction. And I said when it's fraction equals fraction, I just cross multiply. That's what I'm going to think of this as, is 9 over 1 and negative 9 over 1. So I can just cross multiply. 2x minus 5 is times 1. It's just 2x minus 5 equals, what are we going to have right here? Are y'all following what I'm doing? What number's going to go here? 27. Okay, I'm deaf up here. So, we know how to solve that now. 2x minus 5 equals 27. What would I do? I would move the 5 over. So I have 2x equals, is that a 32? And then divide both sides by 2. So what are we getting? X equals, is it going to be 16? Is that what I heard? Oh, okay. So there's one of my answers, positive 16. I probably shouldn't have said positive 16 because you might start thinking your other answer is going to be negative 16. I don't think so. Let's do the cross multiplying. So we have 2x minus 5 equals, is that a negative 27? Go through those same steps, add 5, so we have 2x equals negative 27 plus 5, is that a negative 22? And then, what would I do to get that by itself? Oh, let me lift this up. I'm sorry about that. Now what would I do? Divide by 2? Good. So we have x equals negative 22 divided by 2. Would y'all say negative 11? So positive 16 and negative 11. See, even though it looks bad, it's not really that bad. Just go equal positive, equal negative, and cross multiply. It's a linear equation. Now, linear, we mean there's no x square in it. Okay. Any questions? Here's the last one. This is again a short assignment, making up for those long ones. 7. Yeah. Absolute value of m plus 7. Then a plus 1 equals 18. Ooh. Let me make my absolute value bars bigger. I don't want this to look like a 71. There. I think I made it look worse. But anyway, There's only one correct first step. What is that correct first step? Give you a hint. Always, always, always. I'm going to put a little cube up here since I didn't write it 3 times. Always, always, always isolate the absolute value bars first. On problem 5, we had to move the 3. Problem 6, the absolute values were already isolated. But here on problem 7, what am I going to have to do first? Subtract 1. There's no other correct first step. If you set up equals 18 equals negative 18, you will get one number correct. But you'll get the other number wrong. And Pearson ain't going to say, hey, you got it half right. You know what they're going to say? You got it all wrong. Okay? So, isolate those absolute value bars first. So we have absolute value of m plus 7 equals, is that a 17? Are we ready to go equal positive, equal negative at this point? Yep. So we write m plus 7 equals positive 17, or m plus 7 equals negative 17. Now, let's move this 7 over. So we have m equals, what's this first answer going to be? 10?
Then it will be m equals 24 on the other side.
Negative 24? Yeah, okay, let me. Okay. Subtract the 7, and we have m equals negative 17 minus 7, negative 24. So positive 10 and a negative 24 are our 2 answers here. Okay. Any questions? Punch that in, and then I want to regenerate this just in my head. Okay? So it's positive 10 and negative 24. I'm just going to say example. Let's try this one. Absolute value of m plus 7 plus 8 equals 6.
You can't do that.
Okay, at first glance, it looks very much like number 7, doesn't it?
Well, you can't do it because then it will be the absolute value of m plus 7 equals negative 2.
Yes, when you isolate those absolute values, first thing you have to do would be subtract the 8. At that point, you'd have absolute value of m plus 7
Equals negative 2.
equals negative 2. The 6 minus 8.
And because it's negative 2, it can't be done. It's an empty value.
Since the negative, it's the number on the right, there is a negative, you would have to say no solution. Oh, here it is where I wrote it. Absolute value equals negative, no solution, or empty set. So if this were a My Math Lab, that's how yours regenerated on My Math Lab, then you would choose. If you look at number 7, I think it gives you that option, no solution. So there's 2 ways this problem might regenerate. One, you get 2 answers, like this one. It's possible it'll regenerate with numbers similar to these that I have over here, in which case then you would choose the no solution or empty set. Okay? Any questions on that? Oh, okay. Okay. Here's something to do. And then there's one other thing we need to review, because we're going to assume you know it on Tuesday. It's not hard. I don't want to have to be reviewing it on Tuesday. Okay. This example that I'm doing is sort of similar to that number 7. The absolute value of x plus 7. The absolute value of x plus 7 minus 8 is equal to negative 3.
That is possible because it is plus 8 on both sides.
Okay.
The absolute value of x plus 7 equals 5.
Have you taken this class before? You're saying exactly what I wanted you to realize. People think, oh, there's a negative number on the right-hand side, so there's no solution. That is not correct. The absolute value has to be isolated. If it's isolated and you have a negative number on the right-hand side, in that event, there's no solution. Tim, say it out loud, because I don't know that you've said it. Always isolate the absolute value bars first. There's that cube there. You're right. Always, always, always. If you're having trouble with this at any time, you didn't isolate the absolute value bars. So what did y'all say I needed to do here?
Plus 8 on both sides.
Okay.
So the absolute value of x plus 7 equals 5.
So I'm adding 8 on both sides, and that's going to give me the absolute value of x plus 7 on the left side. And negative 3 plus 8 gives me a positive 5. And then it falls out real quickly. The stuff inside here, if it's an absolute value equals a positive, so that stuff inside there.
So x plus 7 equals 5 and x plus 7 equals negative 5.
That's correct. That stuff in there has to either be positive 5 or negative 5.
So you subtract 7 on both sides, making it x equals negative 2 and x equals negative 12.
Okay, yes. X equals negative 2, 5 minus 7. There's the first one. Subtract 7 from both sides here. Negative 5 minus 7 gives us
negative 12.
X equals negative 12.
I told you guys on day 1 that I just love math just,
Tim, on the video from 2 years ago, I remember that a student at this point, I'd done something like this, circling the x equal, and she asked, can we type the x equal in the boxes? And on the video, I actually tried. X equals 10. No, no, no. If you do that, it's going to count it wrong. Just the numbers. Okay? Any questions on this absolute value equations? Because that's it for that. But there's still one other thing we need to review. Just because I'm going to assume you know how to do it on, whenever that next class meeting is. Tuesday. It's not anything hard. I want to review. And if it's not a review, if you haven't ever seen it before, it's easy enough, okay? I'm going to tell you a secret. I did not see interval notation until I was in Calculus 1. Now they teach it very early on in mathematics classes, but back in the 80s, you didn't do that interval notation until Calculus 1. It's not anything hard. It seems appropriate since I began today with a number line. Let me go ahead. I'm going to draw another number line. Let's see. What color should I use for that? I'm going to draw a number line. And I'm just going to label some numbers on the number line. Okay. So going from left to right, I'm going to start with some negative numbers like a -7, -3, +1, +4, 6. So I'm not labeling all the numbers on the number line, not that that'd be possible. I've just labeled a few, and I'm going to shade some of these little areas on the number line. Like I'm going to shade between -7 and +7. I'm shading that blue. And at each one of these numbers, which we'll call cut points because that's where you're cutting the number line, I'm going to put a closed circle here and an open circle at the -3. If I were going to say in words what region I've shaded blue, I'd say I've shaded all the numbers between -7 and -3, and not including -7. The enclosed circle means include that number. The open circle means do not include. So I've shaded all the numbers between -7 and -3, including -7, but not including -3.
Because it's an open one, it means that it's like a burning place.
It's
While the closed one means that it's wrapped.
Now, let's see, how about this one? I'm shading all the numbers between 1 and 3.
That means it can only be the numbers that are in between 1 and 4. So
I said 1 and 3, I meant 1 and 4.
It could be 2 or 3.
But we're now using numbers to mean the formal definition of numbers, not just counting numbers. Think of all the decimal numbers. 1.15, would that be in this region?
Yes.
Yeah, so it's not just 2 and 3, okay? It's every number between 1 and 4, but not including 4. 1 and not including 4. And one more, let me see, do I have a good purple pen? Let's suppose we have this. Right out here.
That's every number from 6 onwards.
Okay. Am I including 6 or not?
Including 6.
Including 6. So it's every number to the right of 6, including 6. So if someone tells you to say in words which regions are shaded, you would say, okay, everything between -7 and -3, including -7, but not including -3. Everything between 1 and 4, not including 1 and not including 4. And everything bigger than 6, including 6. That's a lot of words. We have a notation that we use instead of writing out all those words I just said. And it's like you're going to use parentheses whenever there's an open circle and a square bracket. Well, I'll go do that in a moment. Wherever there's a closed circle. That blue the blue region, instead of writing out the words, all numbers between -7 and -3, including -7 and including -3, I would say, since it's a closed circle, bracket
Bracket -7, then do -3 with the parentheses,
comma, -3 with the parentheses. This bizarre little notation means all numbers between -7 and -3, including -7, not including -3. Then I'm going to write what looks like a big U, and it's read union, and that's just how you connect the intervals when you have more than one shaded interval. Like the black interval, how would I write it? I would go parentheses, 1, comma, 4, parentheses, a bracket.
Parentheses,
parentheses. And you might think, oh wow, that looks like one of those ordered pairs, X, Y, if you remember graphing. It does look like an ordered pair, but we're not graphing yet.
Okay? For the 6 because it's including 6 onwards.
Okay. We'd like to have a starting point and a stopping point. In order for this last interval, I'd like to say start at 6 and, but I have no 8s written on this page. What I'm about to write are infinity symbols.
Infinity and
An
negative.
infinity, and over here, negative infinity.
So it will be bracket 6, comma, infinity.
Do you put parentheses or bracket? Well, when I wrote this statement right here, my brother said, or infinities, and I was like, oh, I was going to wait to mention that until right now. It doesn't make sense to say including infinity. Infinity is just representing this arrowhead here. It really wouldn't make sense to say every number between 6 and this arrowhead, including that arrowhead. So with infinities, you always put parentheses beside them. And I'll write a sentence. Always put parentheses by infinity symbols, whether it's positive infinity or negative. Always put parentheses by infinity symbols. On Tuesday, we're going to be going through this little process, drawing number lines and shading regions on the number line. Let's see. 2. It's going to be a 5-step process, something called the cut point method. And you're going to have a little number line drawn, and you're going to find these numbers, like the negative 2 and 4, or these numbers I have labeled over here. And you're going to plot them on the number line and shade regions on the number line. And you ultimately will get a number line like this. How would I write this shaded region here in interval notation?
Bracket, negative, infinity.
Wait, bracket or parentheses?
Parentheses, negative.
Always put parentheses by infinity symbol, so it'll be
Negative infinity, comma, bracket, or comma negative 2 bracket.
Do y'all see that? You're putting a bracket in place of the closed circle.
And the other one.
Always infinity, always parentheses by the infinity symbols. Now, what about the other one? Union.
Parentheses for.
Okay, because it's an open circle, you're going to put parentheses at the 4,
Comma, infinity,
comma,
parentheses.
infinity. Okay. Any questions there?
What is that used for?
Oh, we're going to be solving the U. It just says union. It's a way of connecting the two intervals. Okay? Yes, you're saying they're all the same number line. Okay? If you had several different number lines, you would have, okay, this was on a separate number line, and this over here on a separate number line. You would have put the union there. You would just say, okay, negative infinity, comma, negative 2. It looks like I have a decimal point here. I guess I just touched my pen there. There shouldn't be a decimal point in front of the negative infinity. Okay? So, I don't know what that is. Okay? Another question? Well, this is the end of the third week. We are marching on along, okay? If they get this computer to work correctly, maybe one day we'll stand it here, okay? And everyone will sit over here. But
I'm
y'all
gonna
have to
stop
pay
recording.
attendance. I have to say that Monday, or we do this again on Monday, Wednesday. Oh, wow. Yesterday at about 2:05, this side was still empty.